tens or hundreds or even of milliseconds, or even seconds or minutes, then clients will have perceptibly lower responses. Basically, the long story short is don't try to do a lot of stuff on the server. I don't think it's an issue. What could be an issue is the 1000 hertz, like if we want to handle a lot of requests. If we want to handle, it may not be very scalable. If you want to handle tens of thousands of requests per second, then it's going to become a little bit unscalable. That is not very likely for a dictionary editing application. Main thread then has, yeah, it's something. Main new thread, lock new, check event clients events for us. Pop them off, pop them off, make copy, pop off and make unlock, because we want to lock, and we want to lock this. So, okay, process the event, e.g. deleted entry from tree view. I think this is the only real solution. I don't think there are any other solutions actually. This is the only real solution that allows us to maintain some semblance of user interface on the server. But it doesn't look that difficult, but it doesn't look that, it looks like quite a lot of work. This could be a few hours of work. What's the alternative? The alternative is don't have a user interface, or I'll let it crash. The only other alternative then is don't have a user interface. You know, just hide the tree view and everything entirely while the server is running, which is also alright. And in fact, it may be desirable because it'll be faster and you can have a scalable solution. This solution is less highly scalable, e.g. probably not scale well to tens of thousands of queries per second. Let's see. As an alternative solution is simply server UE. That has disadvantage. You know, that has advantage of potential of performance, better performance, and and higher scalability. But this solution has advantage, which is questionable, if that should exist anyway. But sort of allows a user to do some. It's really bad though, to do some user interface stuff on the server. But you still shouldn't. Yeah, so I think the short-term solution is to have the no UE, and so the moment the server starts running, we just sit almost in a, we have to have some UE to be able to close the application, but we can maybe hide the section window or replace the section window with some special just a message thing. Server is running. So the question is, anyway, process event, finish, press event, e.g. something like this, press event, delete requested entry, update UE, etc. So we have no dangling pointers, that's the main problem, the dangling pointers, and signal the object on which the client handling our server's client handler thread is waiting, saying, okay, stop waiting, I'm done. And that is very efficient. continue here. So this step here, after main thread finishes, it's step 5 below. Step 5 is per below. So basically that signal the object which is waiting at its step 5. And like this problem here that I'm trying to, this thing I was just watching myself from my earlier stream, I'm just trying to decide how to proceed. I want to try to solve this, and I want a solution I can do quickly, like, because I'm tired and I don't want to go to bed. But this problem here, there will still be some period of time if the main thread's busy. That's probably going to be quite rare. I mean, it'll be quite rare. Generally, it won't be a problem if you don't do anything on the server. So maybe we should go, you know, if you start doing stuff, you know, edit, going crazy. Yeah, okay, but we're not going to do that. We're just going to ask the users to chill, just leave the server, you know, may even put up a little message, a little modal dialogue saying the server should be just left unattended. And then I think this might not even be an issue. Although maybe the other way to solve it is, in fact, the very thing that isn't a more correct way to solve it. Yeah, like let's save deleted, okay. Gets a write lock on the document. Blah blah blah. This is on the server, right? And that calls delete entry. And then it should unlock the document. And then it should lock it again to call save. Wait. No, the problem is we call save, but save has dangling pointers. Save causes dereferences to dangling pointer stuff, is it not? Yes, it is. Because delete, so locking it isn't going to save us, isn't going to rescue us from this problem alone, because we're still going to sit with dangling pointers when we hit the save command. The bottom line is, I think, even if we got rid of the UI, I don't think that would completely solve the problem. What if we completely got rid of it? Then yeah, it would. No user interface at all. Would it? What about things like ODBC? Can we safely do all the ODBC stuff from a client thread? Like the problem with ODBC, and like say you're working on an ODBC document as the server, and then it disconnects from the ODBC server, then it pops up this, you know, it's got dialogues in it, like the login dialogue or the auto reconnect dialogue, or yeah, I mean, there's all sorts of things. The question is, in my mind, is do we actually need some way to signal the main thread to handle this things like the save, rather than do it from the client thread? The problem is not per se the saving. I mean, saving a document to disk especially, you can easily do from a thread. Obviously, there's nothing special about that. But the problem is all that code, like it calls this function lemmas saved. What does it call that, and where does it call it from? Oh, what the fuck, this sucks. Well, I guess we could just not do that if we're the server. Let the section window know. But we need to let the section window know, because we want to update the UI to show that something has happened. Maybe what we actually want, if we look at some function like the delete, like this event, and maybe what we actually want is a way to say this event must be handled by the main UI thread, and almost redirect it. And remember, this is pre-delete. Pre-delete. This may also trigger some events. Not sure. Like, instead of suppressing, maybe we should have something like redirect to main thread handler, and redirect, and you have some sort of address of a handler, and then all this nonsense here. This scares me. I don't know if this even makes sense. But basically the idea is all this nonsense here would get built in to this. Could be slow. It's actually the right way to do it. The more I think about it, isn't it? Because really all that's happening, we got a client thread editing the document. Whoop-de-doo. And that, I mean, it calls these functions. You could have a big long function that has lots and lots of events getting triggered. Edit that, edit that, edit that. You know, which causes a whole series of events. And you know, you can't just ignore them all and suppress and allow. And at the end of it all say, okay, done. Well, you could, but I mean, the problem is suppressing this event. If all you do is suppress the event, and your main thread happens to try to reference that entry, you're still going to end up with a dangling pointer. The only way to reliably clear the pointer to the dangling is to make damn sure you do it during this trigger call. But doing this for every single event could get slow if there's millions of them. Imagine this was a game, then how would we do it? I mean, suppressing this event still leaves the dangling pointer at this point in time, because it just doesn't get handled. It prevents the hanging problem we had earlier, but still leaves a dangling pointer. And I mean, we could do all this and tell the main thread afterwards, hey, we deleted an entry, and it could then clear the dangling pointer, which is fine and well. But what if the main thread just happened to be busy doing something anyway on the main thing that's going to be deleted? Well, I guess it shouldn't be. It shouldn't be doing anything, you know, without locking the document. Yeah, okay, yes. So there's a lot of things going on here. But there's a lot of, I mean, because the threading thing is new, there's still a lot of parts of this code that doesn't lock the document. Relock. And I mean, even a simple I'm a bit nervous that adding a lot of locks could lead to critical sections. Not critical section, I mean deadlocks, race conditions, if you're not careful. Relock, lock. Yeah, so I mean, just as an example though, if we go into section.cpp and we look at the on idle handler, right? There, and it's what's this? Tightly refresh selected NG asynchronously. It looks like we already worked on this a while ago. Tried to do something. Just a blind totally refresh selected entry asynchronously. Wow. Looks like I ran into this problem before. I wonder when I did that. Clearly I ran into this problem before, and there's already a partial workaround for some cases. It's funny my brain sent me to on idle. Boom. We're already capturing this in the event handlers. So we could simply add this check as well to event entry pre-delete, and the problem is solved. We just, is it? Not really. Defer UI update. This is the problem. So I mean we can defer the UI update, but I know when I did this. 2016. Well, that explains why I don't remember it. So I ran into a very similar problem already, quite early on in the development of this thing. And I forgot I implemented this quick hack partial workaround for certain events, for deferred UI updates. So this thing itself is dangerous, because if entry is dangling after the delete. So I mean what we could easily do is set the entry pointer to null. That we can do from the thread safely, but maybe just with a simple lock. The whole concept of if we think about this section, if you think about model view controller, actually the data, the model, this is part of the model. The model itself should be separate from the view, and just the model should be possible to edit easily from multiple threads. And the view is like, yeah, just a view on that model. This is, but like what about the tree view? We can't delete it. From the client thread. We can again defer to on idle, do something similar to that hack. No, it's not a hack, it's actually a kind of crude version of what the solution should be. It's not even a hack, it's actually correct. It's just blunt. So the lemma tree could also have its lemma pointer set to null. Or what? What should we do? Do we delete the tree? We're going to delete the tree from the client thread. But non-idle, we pick up entry deleted. And then what? We don't need to delete the tree. We just call set selected entry null. We just unselect, force unselect entry. Is there anything wrong with that? Anything wrong with it is there's a very, very brief few split seconds where you have a dangling pointer and like if you hit on idle, which clears the dangling pointer, if you haven't hit that first, you're safe, you're good to go. But if you happen to hit some other part of the code that dereferences that before the onIdle gets called, then you could be in trouble. Although we could set this to null quite easily. From a client thread, and then just set some sort of flag saying, but still then if the main thread's busy with it somewhere, then you got problems. And I mean, we could prevent that with a lock that gets every time the main thread uses it. But that's everywhere all the time. There must be thousands. There's no way we can reasonably even start. If I use Control RR, preview. I don't know if there's thousands, but there could easily be hundreds. Damn, this is more complex than I thought it would be. Why do I feel like there's a simpler solution somewhere? And now I'm just making it complicated. Maybe I must sleep on it. Let my brain think about it overnight. Look at all these, gosh. Oh crap, there are hundreds. So what is our problem? The problem is we have this whole user interface for editing the selected entry and doing things with it. And now this is 15, 16 years old, and now we've suddenly introduced as a new feature a thread that processes requests from connected clients, and connected clients are allowed to delete the entry. Boom, that's basically the problem. Okay, so now we have this thread. So you have this main thread with a user interface of TLEX, blah blah blah, where you can do things to the selected entry in all sorts of ways. You know, edit it in F1 or in the tree view or in the preview, or just do stuff in the lemma list, like right click on it or right click. You know, there's a trillion things you can do here that have to do with that selected entry. And now, while you're busy doing any one of those things, the client thread could just delete that entry and you're left with a dangling pointer. Psh, Um, the client does lock the document. But this isn't a document. It's a user interface. It is a pointer to nodes in the document. Dangling isn't in the document anyway. Dangling is a pointer to a node that was in the document. This workaround, which I did a few years ago for the edit case, it's not totally horrible. We could just add something similar. Alternatively, we could tell a controller, the controller could intercept the event from the thread. We could have some controller, and the controller knows about the UE as well as the client thread. The client thread could tell the controller, hey, look what we just did. And the controller could make changes to the model within the user interface editing model, which could be thread protected access. I don't think that's the right way to do it. I think a better way to do it might be that last idea of redirecting having some way of redirecting the events to synchronously go to the main thread. That could cause problems if the main thread is blocked for any reason, like a CPU is very busy running a script. Or I think it can happen in ILSA if you just press Alt. But I'm not 100% sure about that. It used to be like that in older versions of Windows. You press Alt, like the thread would just, your processing queue would just stop. But it's probably not. I guess timer events must. I can't remember the details. Anyway, redirect to main thread handler. And this redirect story would be something like I was describing earlier, something like that, or something like this. The main thread will pull some object that gets signaled by. So calling trigger on this event when the redirect is in place will basically This would have to be built into the event stuff. Okay. Trigger. So we could maybe have something, if we have a rear rate handler in place, then effectively what we want to do is add it, pointer to this, psender and pdata, do some queue. Same concept as this stuff, okay? To some locked queue, lock protected queue, mutex protected queue. Signal main thread, okay? That queue is data. Well, the queue, I mean the main thread could just poll. What? Oh no, we want to say plus a signal object. Wait on signal object, okay? Then the main thread polls queue plus pointer signal object. Okay. Funds event and queue actually calls trigger via this pointer that was passed in. And then signal, the signal object that we're waiting on, Avavia. The processing continues, yeah. Now, this would have to be done and it must loop this. Events. This could be thousands. Or what can they be? Well, no, there could be maximum one per thread. Now, this whole thing could get slow. Still feels overcomplicated. I didn't really see a way around it. If we really want to be fancy about this whole thing. Okay. So, but yeah, basically, so while this redirect handler this is in place, then calling trigger that's not entirely right either. Because what if the main thread calls the same event trigger while this redirect handler is in place? The redirect handler in fact belongs to client thread ID. Get thread ID. WX thread ID. I wonder if each thread is a handle. As a unique ID. Thus, so get WX thread get current ID. So we would call something like WX thread get current ID, okay, and that if we right handler and if we right handler yeah, so if then if get current ID equals the redirect handler's thread ID that it belongs to, something like that, then it would only do this. Even if it would only do this basically, push main thread handler, pop thread handler, okay, redirect handler, something like that. Then actually no, it wouldn't be push and pop. We add, remove, something, whatever. Okay. This whole thing seems crazy. Now, it's fine for a few simple little events. It'll probably work really well. It'll probably work really nicely for things like entry delete. But I'm a little bit worried if we're doing something huge, like let's say a client thread is literally importing an XML document and calling thousands and thousands and thousands of little events for each node that gets added to the tree. It could be really slow because every single one would have to be passed to the main thread. You know, even polling at 1000 hertz. It won't be that. Will it be slow? I don't know. These things are fast. These signal object thingies, they're not really slow. They're pretty efficient. Polling it could be an issue, but as long as you loop here, this is really important. Very important. Very important for performance. As e.g., if say you're polling at 1000 hertz, but a client thread is triggering events at say 2000 hertz, you can, or say 10,000 hertz, you're going to gum up the wax quickly. So we loop, so even if we're polling at say 1000 hertz, we'd in that case simply trigger 10 events per poll. But English isn't right. Per poll, per polling cycle, I think. Does that make sense? So then the overhead would, the speed would come down to the speed of these signal objects and stuff. And this whole thing seems complicated. Do I really want to complicate this whole event system, this whole already complicated event system? I want to sleep on it and think if there's other solutions here. I don't know. So what we have currently is suppress and allow, which just leaves a dangling pointer. There's nothing wrong with calling the event, but yeah, that's another option. We could just simply call the events from threads, and event handlers would have to all be just adapted to be on their own in terms of how they handle it. So this giant function, yeah, kind of similar to what's being done you know. We could simply build it into the system. So instead of changing the event system, we just call the events, boom, like whatever, call them. And then in here we'd have to, you know, we could add a new parameter or something, just like a calling thread ID, if we want to see whether or not it's being called by the main thread or not. And then we could just, then we'd have to, you know, the section itself would have to be clever enough. I mean, it could do something like set entry to null, but it won't be able to delete the tree view from a thread. But it would know that it needs to delete the tree view and set a flag like delete tree view in on idle, please, in next on idle or something. And being called from thread. Let's see how it does handle entry pre-delete, just for interest. Entry goes entry p data. Maybe I can get node section entry. Untag from tags list. If in MRU delete it. So this we probably don't want to do from the thread. If send equals this. And just why do we delete it? Yeah, this stuff we'd have to defer to on idle. It's not that complicated. Maybe that's better than trying to put some fancy shit into the event system. It's cool, fancy stuff. I mean, this would be really cool. But it's a bit weird to me because this whole problem of main threads and new stuff is really a Windows thing. And it feels a bit odd to build it into the event system. Like, it's not wrong, but it's like, I mean, these events are very sort of generic little simple things, like they boost signals. Like imagine you build into boost signals something that has specifically to do with Microsoft Windows, you know, limitations of not being able to call GUI stuff from threads, some weird thing. It doesn't feel like this. It just doesn't feel right to design-wise. It's not wrong. It'll work. It'll work cool. But one could even make it generic enough that the redirect handler is just a virtual function. You could genericize this. You could make something like a generic abstract TC event redirect handler. Okay. And this could literally be an abstract class. And then the event doesn't need to know that it's about Windows shit. The event could just have like a vector of event redirect handlers with a virtual function call redirect handler. Okay. And then you could have like a, you know, the whole Windows UI thing redirect handler, which inherits from that. But your event could still just have redirect handlers. And this thing could then just be like iterate iterate equals blah 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 again blah 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 blah. Could just iterate the redirect handlers in an abstract way. That's one way around the design issue. It feels a bit better, but I still don't know if that's like the right way to go. So that could be inherited from that and implement basically this. And this then would simply call blah 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 redirect handler iter blah 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 call redirect handler or start I'm not sure, but anyway, whatever. That feels a little bit better than having the event know about. But it's a whole, I mean, it's so weird. Like, that's what the event system is already. The handlers, it's got handlers. Now we've got to redirect handlers to redirect the handlers. It's, it feels like, yeah, I don't know. It's not wrong. And it would, it's not wrong at all. And it would probably work really nicely. And then we don't have to worry, it would probably work beautifully. There'd probably be one or two situations that don't work properly that we'd have to work around. Obscure things that have to do with but yeah, it would actually probably work very nicely. And the nice thing about it is that we don't have to do anything special. We can just keep any of the millions of events. We just all magically work wonderfully. There's no reason we couldn't put that in the handlers. There aren't that many handlers. And not all of them would even be worried about threads. So we wouldn't have to necessarily build it into right into TC event necessarily per se. We could also just instead do something here, like if being called, as long as you know it's being called from a client processing thread. I keep wanting to call it a client thread, and it's not a client thread. It's a server thread for processing client requests. Okay, being called from it's not a client thread. It's running on the server, and it's a server thread for processing client requests. Okay, client processing thread. Okay, then over here we could do this basically. Boom. So basically we could do this exact same thing. But yeah, and we could have a helper for it. So we have the client thread. Client thread. Shut up. There's the client browser request handler thread. Client thread, stop. Stop calling it that. Just have an electric shock every time I call it that. Right. So yeah, instead of suppressing it, we let it get generated. Right. It gets generated and it calls C-section on event dangerously because it's in a thread. So C-section could be doing all sorts of things. In fact, we could even be busy closing the section. I guess that's a special case. We shouldn't be in here if we're closing the section. Okay, but dangerously in inverted commas, because it's not that dangerous, but it's dangerous. Okay, so then we detect it. We say if we're being called from client thread, then do the story. All right. And in our main thread, so say it could be in the frame on idle or the application idle, on idle. Hey, look, we've already got a function called server update test. Oh, this is a very similar concept. Yes, that's funny. So in 2015, I ran into a similar thing. Here I am. This is very much the same concept, but not the same thing. It's for something different. Same principle though, that we need to call certain things from the main thread. Alright. Yeah, so basically, yeah, we could then do this other story. We have a function called process special process special event thread redirects or something, and that function could have this stuff. Call queue, find event, actually call trigger. This could also be on timer or both. Like every opportunity really we get idle and timer. It doesn't really matter. The faster the better, the quicker the better. It's still not synchronous, is it? It's still not synchronous. Like let's say I'm busy editing in the tree view and it's inside, literally inside some lemmetry editing function. At the very moment the client thread calls entry delete, it's only later gonna do this thing. So it's still not synchronous, we still got a problem. We can solve that by can we solve it by doing something like this? By saying, hey main thread, we want to edit the document, tell us when it's okay. Yes, that's really what we want. That is what we want. We basically want permission from the main thread. We basically want to coordinate these edits with the main thread so that the main thread, so the main thread is busy doing things. I'm busy editing in the tree view, the main thread's busy, okay? And the client thread wants to delete an entry and it just wants to do it immediately. So instead of rudely just doing it immediately while I'm busy with it, we introduce a concept like we set a signal saying, excuse me main thread, I would please like to edit this. I would like to do something now to the document. Tell me when it's okay, when it's safe from your side for me to go ahead. Basically this principle. And this thing, signal object client, could go in the onIdle thing. So instead of that thing, right, we have check if any clients have like a edit request for us. If so, do something like signal the object we need two objects. One for a client to server signal, okay. You're basically saying, okay, go ahead, and then wait on, oh no, it's the other way around, server to client signal, server to client signal object, wait on client to server signal, I wait for client to finish. Okay, that only half doesn't solve the problem exactly. Well, it does make it safe in a way, like I won't be in the middle of a tree view edit. Actually you can be. This onIdle stuff is, you know, I could be in a tree view edit and something pops up a dialog, and a dialog can cause the idle handling. So this actually even being here doesn't mean it's safe. Where would be safe then? An on timer maybe? No, on timer can also be called from man, why is this stuff more complicated than I want it to be? Maybe I must just totally get rid of the user interface. No UI. Just totally delete the section window, delete the menus, delete the menus. We need some menu at least to be able to stop the server. I mean, most servers don't have UIs. Some do, I mean, but it's not typical. There's a command line option in TLAX. This isn't a new idea. I've been wanting to do it for a long time. there's no user interaction, and which is really neat actually. And it was also in development and no user interface. So the idea was you could run it in command line mode and you wouldn't even have, and it would act as a server. No window even at all, no frame. Experimental no UI. Yeah, so maybe I must go back to this concept and run the servers in command line, like no user interface mode. So non-trivial. I must get some sleep.